In this video, I'm going to show you how to make this simple pendulum animation using Python with Matplotlib. Let us start. First, import NumPy, as we will be working with arrays and do math. Since we need to make figures, import matplotlib.pyplot. To create animation, from matplotlib.animation, import funcAnimation. Next, create a figure object using this line of code. The size of the figure is 4 inches wide and 4 inches high. The variable fig represents the entire figure. X is an axis object. Next, I am going to set the limits of x and y-axis. For the x-axis, I set -1.2 as the minimum and 1.2 as the maximum. And for the y-axis, I set -2.2 as the minimum and 0.2 as the maximum. I am setting the aspect ratio equal, that is, the x and y scales are the same, and making the figure layout tight. These settings will change this figure to this one. Next, I am plotting a thick horizontal line as the support for the pendulum. The line is between the points -0.5, 0 and 0.5, 0. The color of the line is brown, and the line width is 8 points. The fixed end of the string of the pendulum will be attached to this support. I take the length of the pendulum as 2 meters, which is 2 inches long in the figure. Theta 0 is the maximum angular displacement of the pendulum. I take it as 25 degrees. So the pendulum will swing between positive 25 degrees and negative 25 degrees from the vertical. Convert the angle from degrees to radians, as we will use that in trigonometric functions. This is the initial position of the pendulum. To draw the bob, we need to know the x and the y coordinates. I put the origin here. So this is x0, and this is y0. In this right triangle, x0 is the opposite side to the angle theta 0, and y0 is the adjacent side. So x0 is equal to L times sine theta 0, and y0 is equal to L times cosine theta 0. Since the origin is here, y0 is negative. So put a negative sign for y0. Write the code to find x0 and y0. Now plot the point x0, y0, which is the bob. The bob is a blue circle with a size of 18 points. Later we will change the position so that the pendulum will oscillate. I name the plot point. Note that a plot can have more than one object, but we have only one, which is just the plot of the bob. To unpack that one object as the variable point, we need to put a comma after the variable. The string is a line, with one end at the origin, and the other end at the bob. Draw a line from 0, 0 to x0, y0 as the string. Like this one, you need to put a comma after the variable string. Run the program. You will get this figure. The period of a pendulum, t, is equal to 2 pi square root of L over g, where g is the acceleration due to gravity, which is 9.8 meters per second squared. Write the code to find the period. Tp is the period. Note that 1 period is the time the pendulum takes to go from here to here and come back here. Next, I split 1 period of time into 200 equally spaced time points using NumPy linspace. The angular displacement of the pendulum is related to the time by this equation, where omega is the angular frequency. I use the letter W for the angular frequency, which is equal to 2 pi divided by the period. For each time in this array, I am going to find the angular displacement of the pendulum. Since there are 200 time values, we get 200 theta values. Next, I am going to draw an arc as the path of the pendulum. As we discussed before, the x and the y coordinates of the bob is related to the angle theta by these equations. For each theta value, I am going to find the x and y values. So we get 200 sets of x and y values. Plot these x and y values as a dashed line. The 4 boundary lines of the figure are called spines. I am adding these 4 lines of code to hide them. Also, I want to hide the ticks and the tick labels. For that, I am adding this line. Running the program will get you this figure. Next, I am going to create 200 figures. That is 200 frames for the animation. Each figure corresponds to one of the 200 theta values. I am creating a function called update. When the function is called, a theta value is passed along as angle. For that angle, the x and y coordinates of the bob's position is determined. Then the position of the bob is updated with the new x and y values. This line of code is to update the bob's position. With the same x and y values, the free end of the string is updated. This line of code updates the position of the string. The func animation is used to create the animation. Fig is the figure object that we created. Update is this function. Since each frame corresponds to a theta value, I put frames is equal to theta. There are 200 theta values, so the func animation calls the function update 200 times. And for each theta value a frame is created. Interval is the time delay between the frames in milliseconds. I have set that to 40 milliseconds. Blit is optional. If blit is set true, all non-changing graphic elements will be considered as the image background. So only the changing elements, such as the bob and the string, are redrawn. That will speed up the process. plt.show is to show the animation. Once you run the program, you will see this animation. If you learned something from this video, don't forget to subscribe to this channel. Thank you.